Hello students, welcome back to the 7th lecture on Poisson distribution. Today we are going to solve the examples on fitting of Poisson distribution. Now today's first example is fit a Poisson distribution for the following data and obtain the theoretical frequencies. The data is number of TV sets sold and number of days. So number of TV sets sold are 0, 1, 2, 3, 4, 5 and 6 and more. The respective number of days are 18, 43, 45, 28, 12, 4 and 0. Now we know that in the theory part we have seen that to fit a Poisson distribution, first we have to find the parameter of Poisson distribution. Now to find the parameter of Poisson distribution, we need to find mean of the distribution, because we know that for a Poisson distribution, mean itself the parameter of Poisson distribution. Now to calculate the mean of this distribution, we considered number of TV sets sold as x, that is a variable, and number of days as a frequency f. Then we have to estimate f into x, frequency into variable. Then you will get 18 into 0 is 0, 43 into 1 is 43, 45 into 2 is 90, 28 into 3 is 84, 12 into 4 is 48, 4 into 5 is 20 and 0 into anything is 0. Then we have to add the frequencies, and that is equal to capital N, and if you add this frequency, that is 18 plus 43 plus 45 plus 28 plus 12 plus 4, you will get capital N is equal to 150. Similarly, we have to add the fx values, that is 43 plus 90 plus 84 plus 48 plus 20, then you will get summation fx is equal to 285. It is summation fx. Then after finding these totals, we have the formula, that is mean of a Poisson distribution is mean, which is equal to lambda, and which is equal to summation fx upon capital N. So summation fx is 285 divided by capital N is 150, and after simplification you will get it is 1.9, that is lambda is equal to 1.9, that is a parameter of Poisson distribution. Now we have the parameter of Poisson distribution, we can write the probability mass function of Poisson distribution, that is p of x equal to e raised to minus lambda means here minus 1.9, that is e raised to minus 1.9 into 1.9 raised to x upon x factorial, where x equal to 0, 1, 2, so on up to infinity. Then here we have the frequency function, that is tx equal to capital N into p of x. Tx equal to capital N into p of x. Now capital N is 150. In the table we have seen that capital N, that is total frequency, is 150 into p of x means probability mass function of Poisson distribution, that is e raised to minus 1.9 raised to x upon x factorial. Now we have to put x equal to 0 in this frequency function, then you will get t0, instead of x we are going to put 0, then t0 which is equal to this 150 as it is into e raised to minus 1.9 as it is 1.9 raised to x, where x equal to 0, that is 1.9 raised to 0 upon x factorial means 0 factorial. Now this 150 as it is, 1.9 raised to 0 is 1, 0 factorial is 1, so remaining is e raised to minus 1.9, and e raised to minus 1.9 from the Poisson statistical table you will get 0.1496. Then multiply these two, you will get 22.44, and that is the value of t0, that is first frequency term. Now to find the further frequency terms, we have the recurrence relation. That is Tx equal to lambda divided by x into T of x minus 1, which is equal to lambda, here it is 1.9 upon x into T of x minus 1. Here T of x minus 1 is previous term. Now we will see how to estimate the remaining frequency terms. Now if you put x equal to 1, 2, 3, 4, 5 and 6 simultaneously in the recurrence relation, we will get the remaining frequencies. Now if you put x equal to 1, then you will get T1, which is equal to 1.9 upon x, that is 1, into T of 1 minus 1, which is equal to 1.9 divided by 1 into T of 1 minus 1 is T0. T of 1 minus 1 is T0, and T0 value we have calculated in the previous step. Therefore 1.9 upon 1 into T of 0 value is 22.44. Now simplify this. 1.9 into 22.44, you will get 42.636. Similarly, put x equal to 2, you will get T2. Therefore T2 equal to 1.9 divided by 2 into T2 minus 1, which is equal to 1.9 divided by 2 into T2 minus 1 is T1. Therefore this 1.9 upon 2 as it is we have written here into T1, and T1 value is 42.636. Then simplify this, that is 1.9 into 42.636 divided by 2, and after simplification we will get it is 40.5042. Then put x equal to 3, you will get T3, which is equal to 1.9 divided by 3 into T3 minus 1, which is equal to 1.9 divided by 3 into T3 minus 1 is T2. Therefore 1.9 divided by 3 into T2, and T2 value is 40.5042. It is 40.5042. Then simplify this. 1.9 into 40.5032 divided by 3. After simplification we will get T3 as 25.6526. Similarly, in the recurrence relation, put x equal to 4. Then you will get 1.9 divided by 4 into T4 minus 1. T4 minus 1, that is 1.9 divided by 4. T4 minus 1 is T3. Therefore 1.9 divided by 4 into T3 value is 25.6526. So 25.6526. If we simplify this, then you will get T4 is equal to 12.185. Then similarly, put x equal to 5 in the recurrence relation, you will get T5. So T5 equal to 1.9 divided by 5 into T5 minus 1. That is 1.9 upon 5 into T5 minus 1 is T4. So 1.9 upon 5 into T4 value is 12.185. And simplify this, you will get T5 is equal to 4.63. Then the last frequency term, that is T6. Put x equal to 6 in the frequency function, no recurrence relation. Then you will get T6. So T6 equal to 1.9 upon 6 into T6 minus 1. That is 1.9 upon 6 into T6 minus 1 is T5, which is equal to 1.9 upon 6 into T5. So T5 value is 4.63. Then simplify this, you will get T6 is equal to 1.4. So these are the frequency terms we have calculated for the given Poisson distribution. Now this all observed and calculated frequencies we have to write in the tabular form. That is, first column is number of TV sets sold, that is nothing but x, which is a variable. Then number of days, that is a frequency, and it is observed frequency, which is already given in the question. And the last column is theoretical frequencies, means whatever frequencies we have calculated, and in that also actual, means whatever approximate values are given or whatever the fraction values are there, that is nothing but actual, what the frequencies we have calculated. And the last column is approximated, means these fraction values we have to approximate and we have to write it. Then the number of TV sets sold are 0, 1, 2, 3, 4 up to 6 and more. Then observed frequencies are 18, 43, 45, 28, 12, 4 and 0, which are given in the question itself. Now if we add these observed frequencies, then it is nothing but capital N is equal to 150. Then actual frequencies, whatever we have calculated, it is 22.44 and we have approximated this as 22. The next theoretical frequency is 42.636 and we have approximated it as 43. Next value is 40.5042, so we have to approximate it as 41. Next frequency is 25.6526 and it has approximated as 26. Next observation is 12.185, so approximately it is 12. Next is 4.63, so we have approximated it as 5. And last is 1.4, so approximately it is equal to 1. Now we have to add these approximated values, that is theoretical frequencies, and if you add this, you will get capital N is equal to 150. You can observe the total observed frequency and total theoretical frequency is equal, same it is 150. It means we have to approximate these theoretical frequencies such that total frequency should be equal to the total observed frequency. Total theoretical frequency should be equal to the total observed frequency. And that is the solution for the first example. Now let's move to the second question. Fit a Poisson distribution to the following data and hence find the theoretical frequencies. Here data is given, x, that is a variable, and f are the frequencies. X value is 0, f is 50. X value is 1, frequency is 24. X is 2, frequency is 8. X equal to 3, frequency is 6. X equal to 4, frequency is 8. X equal to 5, frequency is 4. And x equal to 6 and more, frequency is 0. Now for this question, first we have to find the mean. After getting mean, you will get the parameter of Poisson distribution. Then write the frequency function. Put in the frequency function x equal to 0, you will get the first frequency term, that is t0. Then write the recurrence relation, and in the recurrence relation put x equal to 1 to 6. You will get the remaining frequency values, that is t1, t2, t3, t4, t5 and t6. And check whether you will get lambda equal to 1.1 and the remaining frequencies are 33, 37, 27, 2 and 1. So solve this example at home and check whether your frequencies are same or not. So this is the second question on fitting of Poisson distribution. So please complete this question at home. Thank you.